Good afternoon to our viewers in Germany and good morning to our viewers here in the United States. I'm Steve Sokol, the president of the American Council on Germany. Thank you for joining us today. I am very much looking forward to my conversation with Dr. Reinhard Ploss, the CEO of Infineon Technologies AG. We'll be talking about the global shortage of semiconductors. And it seems as though almost every day I hear a news report or read an article about the supply of the microchips that are required for countless products in today's economy. From personal computers and cars to washing machines and even toasters, microchips are in great demand. For companies like Infineon, this is both a challenge and an opportunity, and I can hardly think of a better person to talk about the current chip shortage and what it means for companies, manufacturers, governments, and consumers than Dr. Reinhard Ploss. He has been with Infineon since before it was Infineon. He started his career in 1986 as a process engineer for chip manufacturing at Siemens AG in Munich, and Infineon was spun off in 1999. Reinhard Ploss rose through the ranks, assuming roles such as the head of the Power Semiconductor business unit, and later as president of the Automotive, Industrial, and Multi-Market Business Group. He's been a member of the management board since 2007 and became CEO in October of 2012. Herzlich willkommen, and thank you for joining us today.
Yeah, thank you from my side. And Stephen, please call me Reinhard and not Dr. Reinhard Ploss. This sounds a little bit unusual to me. And well, I wouldn't know whether or not I'm meant.
Reinhard, thank you so much for that. It's always funny, going back and forth between German and English, and the different formalities that exist. But I appreciate that, particularly since I have such positive memories of your visit to New York in March of 2018, and an inspirational talk that you gave before the ACG at that time. You talked about the need for constant innovation in an increasingly digital society, as well as the impact of technology in developing responses to global megatrends, such as demographic and social change, climate change, and resource scarcity, but also urbanization. And I was thinking back about your visit in 2018, and at that time, I think very few people could have imagined a global disruption like the COVID-19 pandemic. And the current semiconductor shortage has come largely as a result of the pandemic, and we'll get into that in just a minute, but it has really impacted production and distribution of countless products. And many observers and analysts see this as just the tip of the iceberg and think that the shortages could last for a while. So Reinhard, before we dive in and talk about the current crisis, the current situation, the semiconductor industry, of course, is huge and extremely complex. One chip cannot automatically be substituted for another. So before we talk about the current developments, let's sort of set the stage by talking a little about the production of semiconductors and the differences between the kinds of chips. I'm sure that there's a difference in the kind of chip that's in your toaster or the kind of chip that's in a brand new computer or in a car.
Yeah, Stephen, very good. Let's do so. And for me, it is the variety of chips is very huge. And you said it rightly, it's not so easy to exchange between the chips. Yes, there are some standard products, but the majority is very dedicated to its function. Let me use something which all of us know. And first of all, you have this type of chips who have a huge compute capability, which is in your mobile phone, which is in the server farms, which is managing all the data streams. These are the so-called ultra high integrated. These are those chips which are using the finest geometry. And currently we are heading to 1 nanometer, which is even a fraction, and you mentioned COVID, a fraction of the size of a virus. So it's extremely small, and the driving factor is you want to have more and more functionality on the same chip, and this performance get paid for. The other part is something which I think, let's take something, maybe not in New York, but in US, many people may have, the automatic lawn mower. So it's quite interesting. What do you need for that? So first of all, this lawn mower should be able to recognize its environment. It should be able to process these data and then drive around and sooner or later have everything, I would say, have cut the grass. So what you need is sensors to recognize where I am. This can be camera chips, this can be radar sensors, and many others. These is a very specific type of chips, and they are defined by technology. Technology means how do I manufacturing, because they are interacting with the physical world. The next what happens with this, you process these data. Now compared to a huge computer farm, this is pretty small computing requirements, but a pretty ugly environment, higher voltages, higher temperatures, and so on. I would call this as dedicated medium scale integration, which around today maybe between, let's call 20 nanometer scale and so on. For the chip manufacturing industry, many people say this is also more mature or historical technology. I would not agree with historical, but I would say reasonably mature technology. The sensors, again, as I said before, manufacturing very much specialized. And for instance, also you do this micromachining where you kind of build a real mechanical structure in a tiny chip. So very different. And the final one, you want to run that your lawnmower runs around and it has to turn the wheels, and there is a motor run from a battery. The battery needs to be charged. So with this, you need so-called power semiconductors. Also here, technology 100% different than the integrated part. I would say not 100%, but 70%. Very specialized on managing power. And so these are basically the types, and now a little bit adding on the idea of this lawnmower. Of course, you can have a higher performance lawnmower who does not run around for hours until it has done its job, but is more controlled. It can have GPS inside, it can talk to the base station in order to tell that it needs to be watered or something like this. So you need the connectivity and can add services by connecting to the cloud. So, and this is what we have. So you have more or less this integrated product, more or less computing, communication, from very deep integration, small features to high. Interesting is that over the time, and the industry started, and you, I would say, more or less said, I'm not from the beginning, but I'm for quite some time with it, and everybody had his own manufacturing. And then as it moved on, this changed. And the majority of the companies did not manufacture themselves. They were using foundries, that means companies who manufacture for you. And this industry is today the dominating way in order to do this integrated or standard integrated chips dedicated for function. For sensors and for power and maybe some other special products, you are very much still where you are, that you have your own manufacturing. So that is what it is. And I think here there's also part, this, I would say, everything is manufactured at a few suppliers, part of the challenge we are seeing.
So on the one hand, we've got this ubiquitous technology that is in a ton of products. And I think it would be interesting perhaps for our viewers to hear a little bit about where one might find Infineon technology. I know from past experiences and past conversations I've had with you, it's in credit cards, in biometric passports, but also on spaceships, not just in lawnmowers and elsewhere. So maybe just a quick word about where some of our viewers might find some of your chips?
So when you look at our chips as Infineon, then I would say we do everything but the very high integrated one. Those are used for as a compute engine in the server farms and the mobile phones and communication. We do power, we do sensor, and we do the medium integrated stuff. So when you look, where is Infineon? We are the company who makes enables, for instance, the solar panels be connected to the grid. We help the grid to be balanced in order to, I would say, deliver power where you are. You see us more or less everywhere when it comes to industrial application, running and controlling motors. You see us in the car. I think we are, as we are by far number one in power semiconductors. We are, of course, strong in power semiconductors in the car, but we are also leading in the car industry. With the acquisition of Cypress, we are also now very broad in all which is the IoT devices and moving there. So I would say it is highly likely that some of your devices receive the performance because Infineon is inside. If you would ask me where we are in, I would say, ask Stephen, do you have another 3 hours to tell you? But I would say these are the major domains. Infineon's capability is automotive, industrial, managing power. But it's when you ask me what is the biggest title, we want to connect the real with the digital world, and all of these types of lawnmowers, automatic cars, smart washing machines, and are powered or empowered by us, and extra performance comes from getting connected with the cloud. So that is where we are. So we are more the real life people and not only the data people.
Thank you for that. I think that's a great way of describing it. And I actually now wanted to turn to the spike in the demand of chips. And we actually have a viewer question that ties in perfectly. One of our viewers writes, can you describe why there is currently a shortage in various types of chip? And another viewer wants to know what sort of raw materials or resources are needed for the production of chips, and whether that is contributing to the shortage at the moment as well.
Okay, so let's take a look back 1 year. When the crisis, the COVID crisis or COVID pandemic started, what happened is this, I would say, homeschooling, work from home, were pushing the demand also, I would say, watching TV or whatever, or not TV, I would say video on demand or whatever you do there, a huge demand was coming up. And this demand was not expected to happen. And I think it is very nice to see that those people who want to have a gaming console, so I do not want to say the brand, but you don't get it. And this shows that there is in general in this domain, managing data, communications, mobile and PC devices. We recently have the biggest laptop sale since many years. So the demand comes from there. The change, how we live, how we work is driving it. Some additional elements are also coming there, because I think here, what you also see, the nature of the device is changing. So yesterday, a laptop was a laptop. Today, you have a lot of cameras, additionally, and so on. These are also driving the demand. So you had additional demand. In order to understand this, you have to go back some years, or I would say just a few ones. And the expectation for the growth of semiconductor was pretty moderate, between 3–5%. Everybody said, yeah, and in semiconductor is slowing down, not so much new. The total industry value chain was not prepared for a growth which we have seen in the last time. What happened else? Many companies shut down and the production was suspended. And of course, I heard it from some foundries in some areas, for instance, in automotive, the demand at the foundry, at the chip manufacturing company, dropped down by more than 70%. Interesting enough, the demand never went away. People bought cars sitting on the parking lot at the dealership and so on, and ordered cars. Now the industry, and not only automotive, is catch up. So you see, we have an overloaded pipeline already from all of data and devices from there. You get a catch up, and you also get a growth in general, most likely from IoT and other devices. So what you see that unprecedented, these driving factor comes together. Normally, some verticals are strong, others are weaker, and it somehow evens out. But in this case, it is very special. So for those people who are in the industry for longer, we had a similar situation in 2000, but this was a different type of crisis. When you remember, the mobile phones were sold out in 99 or something, like 98, 99 Christmas time, and everybody said, this will not happen again, and everybody put a little bit on top for the order. So we, at the same time, with the business hype, everybody also was saying, I need more. But this was a crisis of unreal demand. As people recognized that it's not needed, and we have a lot of dark fiber, we have excess capacity in the mobile. This was vanishing quickly, and we were even dropping significantly. In the aftermath of the Lehman crisis, we also had something, but there it was certainly also, to a certain degree, also delayed demand. So we have a situation which is unique, which is also to a certain degree pushed by the geopolitical dispute, because here some manufacturing sites cannot be used anymore as is, and everybody is saying, I protect my own home turf. And during all of these allocations, we see that people start to order more than they might need. When the allocation is over, you might see the real, but I believe we will end up this time in a completely different crisis, and it's the crisis of effectively more demand. And this topic of, I would say, catching up with the lost business catch up sooner or later might be over. The additional demand has to be managed through. And then there is another topic, which is very specific to the semiconductor industry. Normally, the foundries are adding capacity at the most advanced technology nodes. And it's like a bandwagon, everybody who can moves there. But this is decelerating. And with the sensors, be it camera chips or others, in this, I would say, more mature nodes, you have additional demand. And a lot of the crisis you see today in automotive comes from the fact that you have a bucket in capacity, which is specifically overloaded because there are not only general increased demand, but also the collision of specific needs.
So one of the things that I remember talking with you about a couple of years ago when you were here was that it often takes several years to actually produce the technology to develop the chips, but that sometimes the chips only have a shelf life of 6 months to a year. How does that process tie in with the crisis of more demand that you were just describing?
So let's put it in bits and pieces, Stephen. And I think let's take out the development for some time being, but let's think about the manufacturing first. So when I think about adding new capacity, and I need a new manufacturing site, means a new plant. Normally, these buildings are pretty complex, and the infrastructure, it takes about 2 years until they are ready to start production. The production of the highly advanced chips until they go for delivery is half a year to 3 quarters. Well, if you are bright, you start ordering equipment for your new plant when you start building it. If you want just add capacity, the time for equipment is also about a year. So you see, I always compare it. A truck can accelerate very slowly. It takes a very long time. But if the demand drops, Infineon or the industry in total is able to decelerate quite significantly. Now the market dynamics are not at all fitting to this type of, I would say, what you have is maybe a race car accelerating and decelerating, and you should manage this with a truck. So that is the key comparison which I have on that side. Then the next point is, you rightly say, you can put products on shelf, but in order to manufacture it in the equipment, you cannot let them sit for endless. After 6 to 12 months, you have to have used those. And there's another effect. Many of those get outdated, not because they are getting too old, because all the industry has moved on. So the compute chip of yesterday is today not anymore relevant. So it is a matter of being outdated because of performance. And you sit on a pile of stuff which is great or which was great. Therefore, we have to stay very close to what is required. And when you see the changes, you cannot pre-produce for a very long time. You may, Stephen, when you have a very good understanding that this is the cars which I will build, this is what goes in, then we can agree on this is the pre-build for it. Or when you have other infrastructure topics which don't change so often, then you can say, this is what we pre-built. And then you put a lot on stock for this. And for quite some time, Infineon was better off than the competitors because we had quite some stock. We did not decelerate so much. But now I would say that the value chain gets empty and our stock is used up fairly so far. So that point of development is a different one. And I would say developing such an advanced technology costs you, until you really could say I can produce it, between 3 and 5 years. But only if you have developed the last generation of technology. If I would now say I start at this, whatever, 2 nanometer technology, no way. I would have to go through the nodes, or maybe I can jump something, but I cannot jump from here to the very end.
So, Reinhard, I mean, certainly over the last 30 years or so, many manufacturers have seemed to embrace just-in-time production and very lean supply chains. As you've touched on, they've outsourced production of certain elements for their products abroad. They've cut their inventory of critical components. To what degree did sort of just-in-time thinking contribute to the current shortage? And can you talk maybe a little bit about some of the supply chain disruptions, not so much that have affected Infineon, but that have affected many companies that are dependent on chips today?
Yeah, it's a good question. I think what we here I would approach it from a different angle. First of all, I agree with you, just in time is a problem. But the basic wrong assumption is that you have endless supply, that you can accelerate and get double of it, but this is not true. The semiconductor industry is very capital intense. Such a new factory at the leading edge costs 10 billion. You cannot have a factory sitting idle. Anyhow, that is not stable. So we have to run it, and we have to keep it fairly loaded in order to be profitable. Now, when you decelerate and accelerate, you are like in a traffic jam. There are portions where you can drive and where you have a standstill. And I think that is the biggest problem. We have to you can use this just-in-time delivery concept when everything is steady state. But you cannot use it when you are in an unsteady situation. And the COVID in last year created a significant unsteady situation. And in order to catch up, you need ample capacity. You can do that, but you have to pay for it. You have to be willing in order to say, oh, my production is better to do in, let's say, just in time. I only look at the very critical parts, and maybe there are people, and I do not now want to say it is, but look at this, typically at some of the industries, adding capacity is not so difficult. Some of the industries are manufacturing 5 days a week in 2 shifts. You add a shift, you add the weekend. You have more capacity. We anyhow do 24/7, no stop. And therefore, you have to identify critical industries where the flexibility is limited. And this is a consideration which we should do as industry in total when we think about resilience. It is identifying areas in a scenario thinking which don't have the flexibility in order to cope with it. And flexibility also can come from the fact that I can add capacity, I would say, in a few weeks. So for instance, when you look at COVID, the mask production could be solved in a certain number of weeks, still a problem, but it can be solved. You cannot solve it in semiconductor. So resilience is a matter which we should look into more deeply and then differentiate between what you can do without major buffer stocks and so on, and which not. And I'm happy to have some extra capacity in order to serve it, but I will not be able to finance it all by myself. So you see that the majority of the industry, which is very outspoken, is to date automotive industry. And this is very easy to understand. You have a car, 30, maybe $100,000, and then there is one chip or several chips worth maybe $100 in total. And you say, well, guys, it is unbelievable that we cannot sell this car because of just that bucket. And of course, the consequences are the most one, and looking at the variable earnings, that means when you do an additional car, that is very significant money for the companies. But we see currently, I do not know how it's in US, but if you order a new kitchen, normally you will be told that, well, you can order one, you get the furniture, but the equipment will come maybe at Christmas time. So there are many more industries. I talked about the gaming console, same, which are affected, but not so visible. And somehow who survive the problem in a different manner by delivering later or by adopting to what you do, or even going for some older products or whatever they squeeze. The automotive industry doesn't have the flexibility, and others even don't have. So you see the effects of this, I would say, supply chain under pressure, and very much in automotive. And we talk about the absolute demand currently, but we have also to think about the irritation, let's call it, of supply, because especially in Asia, we see that some countries are very and increasingly affected by COVID. And also Infineon sees that we have to take extra measures, which of course hampers the capacity we see. So it's an additional unusual portion. Anyhow, I'm very positive about the fact that we could manufacture so smoothly, but I would not bet that it will continue. So for instance, I have heard that Vietnam is shutting down partially, not affecting us. So it's curious how that will move forward.
Undoubtedly, there will be a lot of developments in the months ahead that we'll all be watching closely. I'm happy that you brought up this issue of resilience, though, because I think that helps temper the outlook for the future, as well as the current situation. And I wanted to ask you a little bit about the investment in infrastructure that governments in the US and in Europe are talking about. People tend to think about traditional infrastructure projects like bridges, roads, maybe even internet access in rural areas, but not necessarily about supply chains for products like semiconductors. And so I guess one question that I would have for you is how much emphasis should there be for people to be thinking about critical economic infrastructure like semiconductor production? And related to that, there has been a push by the European Commission to consider plans for a European semiconductor megafactory. And you said industry can't be responsible for this alone. There needs to be support from elsewhere. How likely do you think it is that this might become a reality?
Yeah, it's a quite interesting question. So the biggest trigger point here is for me the geopolitical tension we see. The semiconductor or global infrastructure worked very well. It's anyhow no problem because these products are so lightweight that you can fly it around the globe. And I would say it doesn't matter where the factory is, but that has changed. And it has also changed not only because of the geopolitical tension, but this has significant effect, but also that as semiconductors are so, let's say, relevant for all the industries that you may say before I allow to export it, it has to be reserved for the local industries. So you see also with the current learning that there may be other mechanics or other concepts and problems may show up. And therefore, there are two things. First of all, and this is nothing new. Semiconductor already very long ago was a topic of strategic positioning of industries in the various countries. I can remember when Japan was entering and really desired to be the manufacturing hub for semiconductors. It changed over the time, whatever. Now Asia, Southeast Asia or China, Greater China is one of those. But I believe it is, from a resilience point of view, important that there is, how should I say, a certain even extra capacity or globally in order to avoid that we get stuck because of local interests, because of geopolitical tension, and we would threaten too much of our industry by this, and the collateral effects would be too high. So you can consider this as even like, let's say, coal and oil, whatever, as a basic material. I would not say semiconductors are a material. Therefore, it makes sense. And I would say we have passed an area where this is, I would say, a completely globalized industry. It will bring a lot of, I would say, challenges, because now we start to add capacity, quite some capacity is around. Many people are nervous already today that we will add much more capacity, which will lead then later to a price war in order to fill the factories. I would say that then we have to sit down as an industry, as global, a total industry along the value chain, and say, okay, understood. We are willing to pay a little bit more because you have underutilization, but we have the resilience. We pay for resilience. And I think that this will be a completely new approach. Nevertheless, there is a lot of well-organized, or organized is wrong, there is kind of a manufacturing environment which works well. And now when we add capacity, in areas which are lagging, like Europe, or which are, I would say, want to pull it back, we have to put money on the table, which does have a limited business plan. because I would say, you put it on top. If you put it rightly on top in the right buckets, then you will add capacity for those areas which will see growth in near future. Therefore, I'm not so nervous, but I think we have to do it wisely and together, and even may work together on considering the geopolitical situation, that we say, okay, there we collaborate, there is what you do, we do, and so on and so forth. But I think this will make sense. Nevertheless, I believe it is important that we become aware of the critical, I would say, critical infrastructures and which are here enabling, and that can be the semiconductor, as we also recognize in medical that there are, I would say, productions which are also considered to be critical. I'm a big enemy of, I would say, I'm not a friend, let's call it, that you have everything at home. It is better to look at where can I catch up quickly, where can I survive without, but where is all of these catching up a process which is basically impossible because of technology lag, or a process which is additionally challenging because of ramp lag, I would say getting it done lag. So I would say, yes, the government should think about it and support it to degree, but also, and now I come to a point, ask the industry to come together and say, we will support in the one or other way. Why not inviting automotive industry to participate in such investments and say, okay, guys, we now make kind of a joint collaborative use case out of it, and you have a higher flex, fine, we do it together. But I would say, you see that when you look at to Korea, how much money they want to put into semiconductors, Greater China, Taiwan is pushing, Europe, I think the efforts in Europe are still to be considered as very limited, considering that's what happens in other states. I like the 50 billion, I would say, decision in US is a very valuable one, and I think it is right to be done. And I think that the dialogue, which I believe between industry and government in US, we also had been part of a dialogue with Secretary Raimondo. I was very impressed about the openness, the insight, and that it was very fruitful. And I believe we need more of this.
So in light of what you were talking about with the geopolitical tensions that exist and the developments in other countries, you talked a little bit about Taiwan, China, South Korea. It seems as if a lot of people in Europe, and there have been a number of questions from our viewers about this, think it's time to reduce European dependency on Asian countries when it comes to chip production. And so, pulling the resources really to Europe to be more independent is one way to go. But if I'm hearing you correctly, it sounds as if that's something that might not happen very quickly. And so I'd like to read a question from one of our viewers that might serve as an opportunity for greater transatlantic collaboration. One viewer writes, in light of the many recent US-EU discussions about China's threat to our economic competitiveness and national security, is there an opportunity for a policy of, quote, transatlantic first in terms of semiconductor production, supply chains, and greater collaboration on these issues across the Atlantic? Basically an effort to achieve some transatlantic onshoring to reduce dependence on Asia.
Well, how should I start with the sentence? First of all, I'm not a friend of being against something. I'm much more in favor to do something for the better. Now, this collaboration could be a great opportunity, and it has several reasons. When thinking about Europe, yes, of course, it is a need for Europe to think about. But when you think about the strengths of Europe, it is not necessarily in the compute and communication domain. We have had some computing industries with Siemens, Nixdorf, and others basically gone. So what we are missing to a large degree is the demand for this type of chips and the collaboration with these industries to create them. We are strong in automotive industry and some other segments, and there we can generate the demand as the local semiconductor companies. Of course, we also serve the need in these topics for a global. So in order to, Europe's challenge is to catch up or to grow, or however you call it. I do not want to minimize Europe. We are excellent in doing fantastic machines and highly reliable and performance cars and. A lot we can. But when it comes to digital, in a large degree, we buy something somewhere. So Europe would have to catch up in this domain too. Now, catching up in the digital, catching up in the semiconductor will be very challenging. So I believe a collaborative approach, which of course needs, and then take me wrong, I always have been a fan of our friends in US, and I have very good relation over there. But we need reliability in this relation. We cannot say, okay, now this is the day of the transatlantic first, but about 1 month later it is California first, or whatever it is. This doesn't work. So we have to find ways how we can establish this in a reliable manner. And then I'm, of course, say, okay, guys, why is the current development a little bit alerting? Because if you do things several times, you burn resources for nothing. But as we start to do, we should minimize burning, because doing technologies 2 times, doing manufacturing 1.5 times is not so effective. But the world is a world, and we have to take that step and do it wisely under these conditions.
Reinhard, you talked earlier about the role of technology and the role of the work that you do in thinking about the future and future needs. And in several recent interviews, you've emphasized the environmental aspect of the work that you do. You've talked a little bit about how countries are trying to reduce their CO2 emissions, and have said that a digital infrastructure is more important than ever in order to do that. Can you talk about how the technology that you're involved with can help address the climate challenge that is, of course, of great importance to all of us, regardless of where we live?
Yeah, thank you, Stephen. This is very interesting. When you look back at the history of Infineon, even prior to Infineon, Siemens time, we were a technology company. We had great ideas, and then, well, off we go. We even had not been so fantastic in marketing, at least Infineon now. And over the time, we thought about where will we go? And what we said, we will consider the needs of the society, the needs of all of us, because that are the most long-term and reliable drivers. And one long ago was, at that time, we called it energy efficiency. We thought, okay, you should think about how you make best out of what you do, and you don't create waste. Over the time, we said we have to think about how we contribute to 2 things. First of all, people should have a good life. On the other side, good life should be enabled at low, I would say, not burning resources or not using resources. We call it do more out of less. Now, looking into this, then we are engaged in, well, and now you can debate whether or not that is highly effective. But if you think about today's cars, the miles per gallon, which you can achieve, is much more. The move to electric cars, we enable. We have everything which is needed to harness the power by charging the battery and, let's say, turning the wheels. We address these topics of if you do not want to use coal, oil, or other types of resources contributing to CO2, what is your option? You go to renewables, be it hydrogen or be it electric. Electric is easier to handle than hydrogen. So there we are in the middle. We are in the middle when it comes to connect the solar, wind to the grid, managing the grid, making most out of this power when it comes to efficiencies of power supplies, of whatever you do. Is quite interesting when you think about all the motors today running on Earth. You can save 30% of electrical energy just by changing from old type motors to new type motors. We call it DC brushless, and a speed control for it. So here you see, again, the idea is pretty simple. Technology is an enabler to get more. And then, of course, when it comes to battery operated and all of this, there are great ideas what we can do. Personally, I believe beyond what Infineon is doing, that world like we have to think about making best out of the resources that are around there. And when you think about digitization, managing, let's say, demand and supply, thinking about where to plant crops and so on, how to manage this at best. Digitization is the only way to optimize our highly complex world for the better of the human being, and artificial intelligence will support us there. And at the end of the day, our life is real, and not only in data. So if we would all live, I would say sooner or later, be only a avatar living in a computer, maybe we would need less resources, but that's not our desire. And this is why we said as Infineon, we contribute, and we contribute in a manner by managing the connection and managing the real world and the connection to the digital world.
Reinhard, one of our viewers is curious how you balance focus on sort of current supply with future production, if you will. He writes, how do manufacturers manage supply for current product demand versus new product demand, i.e. R&D and innovation? And he uses the example of electric vehicles. Do manufacturers delay the introduction of electric vehicles, or do they abandon production of current model cars? How do they choose? And I guess for you, how do you make those kinds of decisions in terms of the R&D arm, but also the production arm of what you do?
Yeah, that's a good question, Stephen. I like that. Basically, semiconductor, and maybe now that is confusing, is pretty simple. Semiconductor is pretty simple because there will always be the next technology, and we will always put more features inside. So the one is, and this is something which is going on until you really run into, I would say, physical barrier. And I would say physical really by physics. Therefore, we have a set of basic learnings, we call it golden rules. So first of all, this move on with the technology. If you stop doing this, sooner or later, you will be out of the game, so you have to continue. Manufacturing has to follow it. Those where we do our own manufacturing, we have, I would say currently the growth we are doing and allows us just to put in more equipment and of course abandon some of the old ones in order to do these technologies. But I would say there is a constant, I would say, add-on. In some areas, we also have technologies which are less complex, which are reusing the equipment which is, I would say, left over by those technologies which are moving further to higher complex manufacturing. And that is the same when you look into the foundries. And I think I mentioned it at the beginning. When you look in the 10 years ago, the size of the high-end computer chips was around most likely 40 nanometers. Today, they are down at, I would say, 2, 3, 5 nanometers. But there's somebody else coming, and this automotive says, oh, I'm very happy to use that 40 nanometer technology bucket. But you see that there is kind of a train going through, and this goes. But at the end, sooner or later, you have to, I would say, abandon some of the capabilities. Our factories, I think we have closed some. On the other side, I think the good thing compared to previous is a lot of the equipment is kind of a standard equipment, and you can use it for a much longer time than before. Now, we always say we believe in a certain standard growth around, a target operating model means 9+% growth through the cycle, means all of ups and downs, which you see, so averaging out happens. We assume a certain price erosion, and this leads to a certain production volume. And according to this, we build clean rooms. We build it even so we don't know if it is needed or not, or let's say if it is needed this year or the year after, but it will be needed. If I would start to build it when I recognize it, the only thing which is for sure, I'm too late. Therefore, many things are done based on common rules. And this is something which is also guiding our technology development. As in the high computing part, you always go smaller. In our products, which we do with power, you always say, oh, you get always more power out of the smaller chip. How it is done, well, I don't go into technical detail, but you can assume that you have to, instead of a whatever tiny wire, you need very thick copper wires. And this is a comparison. You do not have real thick copper wires on the chip, but you move on to the next generation of material. So these basic rules of semis, you put into your basic plans and you execute on these.
Thank you, Reinhard. As we start to wrap up, I'd like to maybe ask you about Standort Deutschland. In so many ways, Germany has been a model when it comes to research and innovation and Wissenschaft. Is Germany still a leader? And are there areas where investments need to be made and where Germany needs to catch up with others? What are your thoughts on that as somebody who looks at the landscape in Germany, as you will?
I think Germany has a lot of capabilities, and nevertheless, being a CEO, I tend to look at things differently. I do not look at things and that is good and it may last. I look at things, let's assume it's not good enough and it will not last. Because if you had made the wrong assumption on that, the only thing is you will be out for sure. So that means we have always to think about how to move on. And I believe in the topic of digitalization, artificial intelligence. Now let's, I would say, talk about these more because I'm not an expert in medical and others. I believe Europe has to make the move and do much more in order to grab it. It can be in collaboration with, I would say, US and others, but I think you cannot give too much away because semiconductors is so far an interesting animal. I'm not so sure if you did, but when I was a young boy, and of course, I looked into my transistor radio and looked inside, and there have been a lot of components. The semiconductor industry at that time had no clue about radios. It had clue about transistors. Today, the transistor is a tiny edge on a fully integrated chip, and all the know-how of the radio went to the semiconductor industry. So we are like a Pac-Man eating into the know-how downstream. And we don't do that because we are bad people. We do that because only this is the way to create more performance and reduce cost. And I would say that is a general trend you have to consider. And when you do not move on, somebody who is in the value chain will, I would say, you will eat you for breakfast. And I think that is something where I would say I'm a little bit paranoid and say we have to generate more know-how. And I think the automotive industry is a good place to be and take it from there, creating the autonomous car, working together. And here I always tell the politicians, well, why not working more closely together? It's not I would say an undue collaboration, but today we are a little bit overly religious in order to not talk to each other. So therefore, I would say Europe as a historical model was, I would say, competing and collaborating. I think we collaborate not as much as we should, and the digital transformation could be done much better by a stronger, I would say, more extended collaboration in the due way, but supported and say, orchestrated by the politicians. So with this, I would say, as always, let's get going. And just one comment, very many people say the young people in Germany are not daring, do not try out, and everything is very formal and less risk-taking. That's not true. The people which come into the company, they are very much interested in trying out. What we do is, very often we train them not to do. So, and therefore I would say we must be able to say, do this very diligent in order to achieve the high quality which we need in cars, industrial and others. But this is a topic where you may try out, and we know it's try out. And if it fails, we fails. We create an environment and even names for what we are doing. And that is an expedition project. I even don't know if I arrive or not. But this one is a highway project. Mm-hmm. You sit on and you drive, and you should know it. And therefore, this is something which we have to manage. And I wouldn't say Germany is not able to. I would say we should invite for more of that.
So Reinhard, it's interesting listening to you talk about competition and collaboration. And of course, competition is often seen as a four-letter word, but it's not a bad thing because it means that everybody needs to be at the top of their game and needs to do their best and in order to achieve even better results. But I also thought it was interesting to hear you say that you engage with politicians and recommend to them that there be more collaboration, that we work more closely together. And so as a final question to you today, given that 2021 is an important election year and there will be a new government in office, we don't know what that government will look like yet, but there will be a new government in Germany. Chancellor Merkel will no longer be the chancellor. What are the one or two recommendations that you would make to the new government, or areas where you would say, this is where we could use your support?
So I think what is always very helpful to think outcome oriented. What is the result we want to achieve finally? And the next step is the way to do it. So what my recommendation is for German government, and everybody is talking about environmental, CO2 reduction, I say, well, let's sit together and think about how we can contribute most, even on a global level and not only in tiny Germany, to reduce CO2 emission, to maybe help the developing countries in order to move on at less CO2. Maybe the €1 invested there creates a better improvement or better reduction in CO2 than cutting back here. And so we should think about more on a bigger picture than on the tiny one. And then thinking about how can Germany contribute by doing and not by not doing. And because each time you go for the not doing, you take yourself sooner or later out of the game. And if you have the desire, and Germany should have the desire, to be a contributor on the things which are necessary and important to our future, you should think about the doing. And you know what doing is? I have a goal, I have a concept how to, and I make it happen. These are the messages I would give to the next government, and also the message the industry should not hide behind and say a lot, I would say, voice a lot of claims. They should stand up and say, this is a way how we will be contributing, and this is a way how we can contribute. And this is very challenging to us, and this is a way of no go.
Well, Reinhard, I think this was a great way to bring the conversation to a close, because it provides a forward-looking viewpoint. And obviously in the work that you're doing, you're always looking forward, but it's also a positive outlook. We face a huge number of challenges. Of course, there are big challenges in your industry and in your sector, and we've talked a little bit about those, but I think you're absolutely right. By being goal-oriented and developing a plan to meet those goals, to meet those challenges, we can ultimately get through them. So I want to thank you for making the time to speak with us today. I hope that we'll have an opportunity to see each other again before not too long, here in New York or in Washington or in Munich. But until then, I hope you stay well, and I want to wish you and your colleagues all the best.
Thank you, Stephen, and thank you, of course, everybody listening. And of course, Stephen, looking forward to meet you in person and meet the colleagues who are listening in the same manner, in order to have a real dialogue, because I'm so keen to hear what they think. And, you know, if you have a two-way dialogue, the outcome is better than a one-way.
Exactly.
But your questions were the right one, thank you very much for asking the question and giving me the opportunity.
I was just going to say, I was going to thank our viewers for some great questions today. I know we couldn't get to all of them, but keep the questions coming, and we look forward to continuing the conversation with you.
Thank you so much.